Hello everybody, thank you for watching. This is our 3.6 orbital diagrams video. So what I want you to do is please pause the video and try this do now. I want you to write the noble gas configuration for fluorine. So hopefully your answer kind of looks like this. We're using the noble gas that is before fluorine, and in this case it's just He. And then we start right after our noble gas, so that's 2s2 and 2p5. So what we're going to learn in this video is how to draw orbital diagrams showing electron spin. So previously, when we talked about the rules for electron configuration, we talked about Hund's rule. And if you remember, Hund's rule basically says that when you're filling in electrons into orbital diagrams, they fill in first before any pairing occurs. So I like to give the analogy of a school bus. If you're on a school bus, you always try to find the seat with the empty seat first. So you like to fill in all the empty seats first, and then lastly, if you're that person that comes on the bus, you have no choice but to sit next to somebody over there. The same thing is kind of with electrons. They like to fill in first in these empty spots, and then they like to pair up. And if you remember, we talked about what our up arrows look like in orbital diagrams. Our up arrows are positive 1/2, and it looks like an arrow that just has half of it there. And our down arrow is a negative 1/2, and it looks like this. So let's say you're filling in orbitals or electrons into our 2p orbital right over here. The way that you would fill in these electrons in these dashes is you would first put up arrows. They always go first. And then once you fill in all the empty spaces, then if needed, you can put our down arrows like this. Notice our up arrows always are first, and then it comes our down arrows. So let's talk about the steps on drawing our orbital diagrams. The first thing is first, you want to write the full electron configuration for any element, right? Next, you want to write the first orbital. So whatever the first orbital, it might be 1s, 2s, etc. You want to draw a line over the orbital, all right? So let's say you're doing an s orbital, you only need one line. If you are drawing a p orbital, you need 3 lines. If you're drawing the d orbital, you need 5 lines. And then the f orbital, you have 7 lines, right? Once you draw all your lines and your orbitals, you can then fill in your electrons using our Hund's rule. So let's do a couple example problems. So the first one is, we know that these are the rules for drawing electron configurations. So let me show you what the electron configuration looks like for phosphorus, and then we'll draw the orbital diagram for phosphorus. So if you take a look at it, the electron configuration phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Alright, so looking at the rules for the orbital diagram, you want to first write the full electron configuration, and then you want to write the orbitals. So right here where you see 1s, you want to write 1s here. You can write a dash and 1s. Alright, notice when you're doing your s orbitals, you only need one line over the orbital. Notice I'm also not putting this 2 over here. All right, because our electrons represent the exponents that are there. So I'm just writing the principal quantum number and the block that it's in, 1s. Then I'm going to write 2s, right? And for the p orbital, we need 3 lines, so I'm going to do 1, 2, 3, and right underneath this entire orbital, I'm going to write 2p. Then I have a 3s, and then I have a 3p, right? Now I'm going to use Hund's rule to fill in our orbitals. So the first orbital we're going to fill is our 1s. So we know that this 1s has 2 electrons inside of this orbital. So I'm going to draw an up arrow and a down arrow to represent those 2 electrons. Then in our 2s, we also have 2 electrons. So I'm going to put an up arrow and a down arrow to represent those electrons. Then we look at the next orbital. Our 2p has 6 electrons. So if you remember, Hund's rule says we fill in these electrons by just one, and then if needed we pair them up. So it looks like that, right? The next we have a 3s. Again, we have two orbitals, so one arrow and down arrow. And then lastly our 3p, and here we only have 3 electrons. So I'm going to put 1, 2, 3. And this is correct because we used Hund's rule. We filled the empty orbitals first with an electron, and then we don't need to pair anything up because we only need 3 electrons in this orbital diagram. So this would be the full orbital diagram for phosphorus. Let's try some practice problems. So this is our first example problem. We have the electron configuration already here for you for our magnesium. So now you just need to draw the orbital diagram. So what you need to do is just put our dashes for every s. You only need one. We have a 2s, and again we only need one line. For our 2p, we need 3, and then our 3s, we just need 1. And then you want to fill in the orbitals. So for the 1s, we have 2 electrons. The 2s, we have 2 electrons. The 2p, we have 6. So notice I'm putting them in empty spots first, and then pairing them up. And then lastly, we have 2 in our 3s. So this would be the full orbital diagram for magnesium. Let's try bromine, right? Bromine's a little bit longer. So we have 1s, 2s, 1, 2, 3 for 2p. We have 3s, 1, 2, 3 for 3p. We have a 4s, and then D, remember you get 5 lines. So this is our 3D, and then 1, 2, 3 for our 4p. Right? Notice I'm not putting our exponents in these orbital diagrams. Then we want to fill them up. So the 1s has 2, the 2s has 2 electrons, the 2p has 6, 3s or 3p, and then our 4s, our 3d is completely filled. So 1 in each empty orbital, and then you pair them up, and that equals 10. And then our 4p, we only need 5. So it's 1, 2, 3, 4, 5. All right? Perfect. What I want you to do is pause the video and just kind of go through your example problems on your worksheet, and then come back to the video and see if you get them correct. So this is the complete answer for our next example problem, just prosesium. So if you take a look at this, our orbital diagrams are all numbered with our electrons inside of it. Our last orbital, our 4f, we only need 9 electrons. So if you take a look at this, we have 7 lines for our f, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. Remember to put them in singly first and then double them up if you need to. And this is our last example problem for bismuth. Notice that our last orbital that we have is our 6p, and in our 6p we only have 3 electrons. So there's 1, 2, 3. You're going to fill them in all singly. For the rest of class, what I want you to do is work on your practice 3.6 worksheet, and then you can also finish up your problem set because this is the last lesson that you need in order to finish that. Thank you.